Alright guys, so today we are doing piecewise functions. It's exactly what it sounds like. We're taking pieces of different functions and graphing them on the same graph. So today we're going to focus on what's the procedure, and then we'll look in depth of the functions and how we put them together. So the first thing that we need to be aware of is that what's happening is we are having the graph 2x, which is a linear equation, and this says less than 3. So the graph itself is 2x, but we're stopping the graph at 3. So usually we would plot 2x and keep going on forever, but what's going to happen is we start plotting 2x and we stop at 3. What we're doing at 3 is we're picking up with a new linear function of x plus 1, so the slope's going to be different. So how do we graph this correctly? Well, the first thing we're going to do is make sure that we know where each of these graphs end. So 2x, if we plug in 3, so I'm going to put f of 3. If we plug in 3 times 2 is 6. So we have the coordinate 3, 6. The other thing I want you to realize is it's not equal to. When we have not equal to, it means that point is open. So I'm going to graph that 1, 2, 3, and I go 1, 2, 3, 4, 5, 6. Again, I have an open dot there, point. On the other function at 3, so I'm going to plug in 3 to that function. I'm at, well, 3 plus 1 is 4. That coordinate is equal to, so we're actually going to plot that point. So 1, 2, 3, 1, 2, 3, 4. So at 4 we have a closed dot. Okay. Now we need to figure out where it heads, which side of the graph we have a function. So what we're going to do, guys, and I'm going to keep on with the colors so you can see this, we're going to take our 2x function and we are going to graph values that are less than 3. Okay, so I want to graph about 3 coordinates to make sure I'm in the correct direction. So I'm going to graph 0, 1, and 2. I don't need to include 3 because I already included 3 there. So 0 times 2 is 0, 1 times 2 is 2, and 2 times 2 is 4. So I'm going to graph these coordinates now. 0, 0, 1, 2, and 2, 4. Now is the time to actually use a ruler so we know it's a straight edge. So I'm just going to grab another sheet of paper as a straight edge, because the idea is that this graph will go on forever on the left side, okay, because it's less than 3. So all these points are less than 3 for x. For the other function, x plus 1, we're going to use x's that are greater than 3. So greater than 3, 4, 5, and 6. So I'm going to plug those in. 4 plus 1 is 5. 5 plus 1 is 6. 6 plus 1 is 7. And now I'm going to graph these points. So 3, 4, 1, 2, 3, 4, 5. And we have 5, 6, 6, 7. Again, I'm going to use a straight edge or a ruler. I prefer you guys use a ruler. And there's an arrow because it keeps going on forever. Make sure when you write your answers, you're really indicating right there that it's an open circle. Because if it was not an open circle, we would not have a function, since there'd be two y values. Alright, we just did our first piecewise function. Let's check how it might change. It does say identify the domain, guys. So let's go through that really quickly. Sorry, have to go back. So remember, domain are all your x values, your possible x values. So for here, as you can see, our arrow keeps going towards the left. So it's going to be negative infinity, 2. And here, our green graph here, the 2x, ends at 3, but it's covered by our second piece of our graph. Okay. So that means it keeps going to infinity. Our range is in the same idea, and I'll show you why. Our only issue is this open point right here. But as you can see, we have a filled in point that covers that. So our range is still negative infinity to infinity. Alright, now let's go on to the next. Same idea, guys. That first function is negative 2x plus 1. But as you can see, we're only using negative 2x plus 1 from negative 3 to 1. So we're not going outside of these points. With that, I have to find both those values. So if I plug in negative 3, see, negative 3 times negative 2 is 6. 6 plus 1 is 7. And if I plug in 1, negative 2 plus 1 is negative 1. I'm going to plot these coordinates right now. Let's keep in mind it's equal to for the negative 3. So that's going to be filled in. So 1, 2, 3, and then 7. 1, 2, 3, 4, 5, 6, 7. And again, that was filled in, right, guys? Now we have our 1, negative 1, but that is not equal to, so that's going to be open. So 1, negative 1, and that's going to be open. Next, we're going to look at that endpoint there for x squared, and we're starting that at 1, so f of 1. When we plug in 1, 1 squared is 1. And that is filled in because it's equal to. So at 1, it's 1 filled in. And that graph is going to continue all the way to the right onto infinity. So let's fill out our table so we know where it goes. Negative 2x plus 1. We are going to go from negative 3 to 1. So I'm just covered by negative 2 and 0 because I already have negative 3 and 1 there. Negative 2 times negative 2 is negative or positive 4. Positive 4 plus 1 is 5. When we plug in 0, we get 1. So negative 2. Oh, I guess I could have done negative 1. Oh. Which would give me 3. There we go. Sorry, guys. Negative 2. 1, 2, 3, 4, 5. Negative 1. 1, 2, 3. And 0, 1. Let's connect. Now remember guys, we're not going on forever. It stops here. So I'm only connecting those points. I'm not putting an arrow on because it stops at -3. Okay. Let's do our x squared. So I'll do a couple points there. So we already did 1. So 2, 3, and 4. 2 squared is 4. 3 squared is 9. 4 squared is 16. Alright, so at 2, we're at 1, 2, 3, 4. At 3, we're at 9, 5, 6, 7, 8, 9. And I'm not going to plot 4, 16 because it's off the graph. Let's keep in mind that this is not linear, so I'm not just going to connect it with lines. It's part of our parabola, which has a curve to it. Now I am going to put an arrow on this one because it continues all the way to infinity. In this case, when we identify the domain and range, we need to keep in mind of those arrows, because if we do domain, how far left it goes, it's left at -3, and it's a filled in, so it must be a bracket. And then if we keep going towards our right, we have an issue here, but it's filled in, so that's okay. And then we keep going. This arrow tells me I can keep going towards the right, so it's to infinity. Range is how far down and up. So if I look at the lowest point, our lowest point is at -1. Does everyone see that? But because it's open, that means we must do parentheses. And then we keep going up. Our arrow tells me I keep going up to infinity. Okay, so this piecewise, this one function takes a piece of a linear and a piece of a quadratic. Okay, let's go on to our next example. Here we have a cubic and a linear, so let's see what that does. Alright, we have boundaries again. We're only doing the cubic from -2 to 1, so let's put in our endpoints. So f of -2. Well, -2 cubed is -8. And 1, so f of 1 cubed is 1. Okay. Let's plot the -2, 8. It's equal to, so it must be closed. -2, -8, and we said it was closed. 1, 1 is going to be open, so 1, 1 is open. Alright, let's do our endpoints for our linear here. So we have f of 1. We plug that in, we get 5. And f of 4. Well, 4 times 3 is 12. 12 plus 2 is 14. 1, 5 is equal to, so it's closed. 1, 1, 2, 3, 4, 5. And 4, 1, 2, 3, 4, 14. Now I am going to have this go off the graph just because we know it's not an arrow since it stops there. Alright, so let's do our table so we know what this looks like, because we can't just connect them, right? That would be linear if we just connect them, but it's supposed to be cubic. So -2 we already have in there, so let's do -1, 0. If I do 1, it's already there, so -1 cubed is -1, 0 cubed is 0. Alright, so remember this cube is like kind of our snake. Something like that. And it really does look like a cubic. No arrows. It doesn't go on forever. Now, let's do our linear. So 3x plus 2. So we already did 1, so let's do 2 and 3. 2 would be 8. 3 would be 11. So 2, 8, nope, 8 is right there. Let's get rid of that. And 11. Okay, so now this is linear. So of course, because I'm off the graph, it might not look so linear. So try to let it look as possible as we can. Okay, very good. All right, let's talk about domain and range, especially with endpoints here, guys. So let's do domain first. What is the farthest left? Well, that's at -2, and it's filled in, so we're going to do a bracket. Now, as we keep going right, we have a hole here, but as you can see, it's filled in right here, so we're okay. So as we keep going right, our last point is right on 4. And that was also filled in, so it's bracket. Range, what is our farthest down? Right down here, right? That value is at -8, and that is filled in, so bracket. Now, here is our tricky part, guys. So as we are at -8, as we keep going up, we stop. We stop where? We stop at the value of 1. It's open, so it is a parenthesis. And then what happens is I have to jump and start back up here. What y value is that? That's 1, 2, 3, 4, 5. So we're starting back up at 5, and that was closed. So it's bracket. And we continue all the way up. Do you remember what point that was? That was at 14. And that is also filled in, so it is a bracket. When there is a jump, it means you have to have 2 different intervals, okay? So there was a jump in our y, not a jump in our x's. All right, one more, and then you guys can practice. So we're going to do f of -3. Well, 2 minus -3 is 5. F of 1 is 1. So -3, 5 is filled in. One is not filled in. And then we have f of 1. Well, the square root of 1 is 1, and that is also not filled in. So that stays a whole. So let's do our linear here. 2 minus x. So let's do -2, -1, and 0, because it's in between the two. That would be 2 minus -2 is 4. 2 minus -1 is 3. 2 minus 0 is 2. -2, 4. -1, 3, 0, 2. Okay. when putting these together, don't forget there are no arrows, and try not to fill in that hole there because it's not filled in. Okay. Now we have our square root. One thing I want you to keep in mind, guys, is we want to be able to graph the square root function. So let's find perfect squares for this. We already did 1, and we're going to do greater than 1. So the next perfect square from 1 is 4. Because if we did 2, it would be decimal. The next one from there is 9, and then 16. So square root of 4 is 2. Square root of 9 is 3. Square root of 16 is 4. Alright, so at 4, 1, 2, 3, 4, we're at 2. At 9, we're at 3. 16 would be off the graph, so I'm not going to graph that. Now, it's a square root, so it's that kind of rainbow. Okay, just don't forget, do not close that point. And it keeps going on forever. There's no other endpoint, so we need an arrow. Okay, last domain and range. Domain. What is the farthest left that we see? 1, 2, 3. -3. And that's closed, so it's a bracket. Now, as we go to the right, what happens right here? There's a hole, so we have to indicate that. There's a hole at 1. So we're going to use parentheses to indicate that that's a hole. And then it keeps going on forever to infinity. Okay, our range in here is also a tricky one. So let's look at the furthest down. The furthest down is that hole at 1. So we're going to start at 1, but it's going to be parentheses because it's a hole. Now, here's tricky. I need you to visualize this. As we move up, we have a tendency to say, ooh, it stops right there. Correct? But what you need to keep in mind is this arrow tells me it keeps going on forever. And as you can see, as it keeps going on forever, it will move up. So it goes up all the way to infinity. Alright, try some of that practice on your own.